Hello everyone. Good evening. Welcome to today's session. And today we are going to discuss a very important topic in manufacturing. And it's known as foolproofing. Foolproofing. Fool. What's fool? So it's like this is a word that may sound a little funny. But in the real industry, this is one of the most powerful concepts. So let me tell you something honestly. Machines are becoming smarter day by day, but still mistakes happen. And most of the time, those mistakes are not because people are bad. They happen because the systems are not designed properly. So today, we are going to understand how smart factories reduce their mistakes. It's not by shouting at the workers, it's not by giving warnings again and again, but by designing systems in a smart way. By the end of the session, you will start seeing foolproofing everywhere, not only just in the factories, in the machines, in your daily life, even around you. So, let's start. Let's start with a simple truth. In manufacturing, one small mistake is equal to big loss. Not a small loss, it's a big loss. Let's take CNC for example. As you have learned in our previous webinars, you have learned about offsets and everything. If you give a wrong offset, machine will not stop and ask you, are you sure? No. It will just run. And as a result, what will happen? Within seconds, the part is damaged. The material is gone. The time gone. Sometimes even the tools get damaged. Now think about assembly. Two pieces you are assembling together. For example, in a press tool or something, when there are multiple plates, like a bottom plate, stripper plate, a die plate, punch holder, punch back plate, top plate, punch, whatever it is. When you have to assemble multiple pieces together, if one part is fitted in the wrong direction, what will happen? The final product will fail, right? Customers will start complaining. So here, mistakes are expensive. Even a small mistake becomes a very big problem. That is why we need to control mistake. I'm again telling, we need to control, not reduce. We need to control the mistakes. Now, the question is, why do mistakes happen? Let's be very honest, it's not always lack of skill. Even experienced people make mistakes. Why? Because we are human. We get tired. And after long hours, focus reduces. We get distracted. Someone calls, someone asks something, we lose concentration. Sometimes we become overconfident. We think, I know this, no need of checking. And that is when mistake happens. Let me give you a simple daily example. Have you ever locked your bike, walked like 5 6 steps, then came back again to check? Why? Because we are not machines. Same thing happens in factory. So if a system depends fully on human memory, then mistakes will definitely happen. So instead of blaming people, we improve the system. Now, let's understand the solution. Let's come into the point. Let's come into foolproofing. What is foolproofing? So, foolproofing means we design the process in such a way that mistakes either cannot happen at all, or if they happen, they are immediately detected before the damage occurs. Simple idea, but very powerful. In industry, this concept is also called as Poka-Yoke. It's it Poka-Yoke. This concept was developed to achieve what industries call zero defect manufacturing. Not less defects, not manageable defects, zero defects. Now comes the solution, foolproofing. I told you, foolproofing means we design the process in such a way that mistakes cannot happen, or if they happen, they are caught immediately. Let's take an example. If a part can be placed wrongly, we redesign it so that it fits only in a correct way. Or if a mistake happens, we add a sensor so machine stops immediately. So instead of depending on an operator, we depend on a system. This is foolproofing. Now, I want you to remember one line, very important. If a mistake is possible, the design is wrong. If a part can go wrong, one day someone will put it wrong, 100% sure. So instead of saying, be careful, do not do mistake, we change the design so that the mistakes never happen at the first place. For example, if a charger, if it mobile charger, if it fits both ways, then you will get confused sometimes. If it fits only in one way, you cannot make any mistake. So, what do smart factories do? They don't blame people, they improve design. That is the difference. Simple definition. So, foolproofing means only two things. One, no mistake should happen, or if mistake happens, catch it immediately. That's all. Simply, in simple words, if you explain, seat belt warning in a car. If you don't wear, what's happening? Alarm comes. That is detection. Another example. I hope you all know how we put the SIM cards on a mobile phone. You know, this mobile phone SIM cards, we cannot insert in a wrong way. Why? Because if you see, it is not exactly a rectangular shape. There is a cut in the corner, right? Why? Because that is where it will match properly and sit properly. This is known as prevention. That is, this insertion cannot be wrong, so that is known as prevention. So remember, prevent or detect fast. That is foolproofing. Now, daily life. So foolproofing is already around you. You are using it daily. SIM card, as I told, one corner cut, only one way it will go. ATM card, the strip is on a special side. It will go only in one direction. Gas regulator, if it locks properly, it cannot connect wrongly. Why? So the mistakes don't happen. Even the USB pen drives which we use, always we get confused whether it is has to be taken upside down or how we have to put. It won't go both the sides, right? Nowadays the C types have come. The older type A types, it will go only in one side. Why? This is because this is known as foolproofing. So this system is already working in your life. The same thing we are going to implement in the factories. Now, a simple question. If foolproofing works so well in daily life, why can't we use it in manufacturing? Why should we depend only on skill, only on experience, or only on memory when we can design systems that guide this operator? This is exactly what smart factories do. They don't assume that the operators will always remember everything perfectly. Instead, they create systems that supports the operator. They reduce the chances of error. They simplify the process and slowly they move towards a zero defect production. So foolproofing is not about replacing people, it's about helping people work without mistakes. In industry, the goal is simple: no mistakes, not less mistakes, no mistakes. Because even one small mistake means loss. So the companies try to remove chances of error, and foolproofing helps achieve that. Better quality, less stress, and better production. In many small industries, the goal is like reduce mistakes, but in advanced manufacturing, the goal is different. The goal is zero defects. Now you may think zero, is that even possible? In reality, it is very difficult. Yes, but that is the direction industries move towards. And foolproofing is one of the main tools to achieve this. Because when you remove the possibility of error, quality becomes consistent, output becomes reliable, and customer trust increases. So, this is not just a technical concept, it directly affects the business success. So, now since we have understood what foolproofing is, let's make it even more clear by dividing it into types. Because once you understand the types, you can easily identify it anywhere. There are mainly three types of foolproofing used in the industry. First, prevention, second, detection, and third, warning. Don't worry about the names. We'll be explaining it each one in this very simple way. Just before we go in detail, think like this. Prevention means mistake itself cannot happen. Detection means mistake happens but we catch it immediately. Warning means mistakes happen, system gives alert, but we have to act. So these are like three levels. The best level is prevention. Next, detection. And the last level is warning. Let's discuss a simple daily life example to understand all this. Imagine you are filling petrol in your bike. Fuel nozzle fits properly, no leakage possible. If tank is full, auto cut happens. Warning, fuel indicator shows low, but you have to take action. Right? Fuel indication shows means you have to go to the petrol pump. Same ideas in the factories. Now in the next slides, we will see each type clearly. Prevention type. First type and the best type is the prevention. Here, the mistake cannot happen at all. Not reduced, not controlled, completely eliminated. This means mistakes cannot happen at all. This is the strongest type of foolproofing. Let's understand slowly. Look at the example in this image. You can see a part which has to mate to each other. It is designed in such a way that it fits only in one direction. If you place it in the wrong direction, it will not simply go in. It won't mate. Now think about this. Does operator need training for this? No. Does he need to remember anything? No. Even a new person, even a beginner will place it correctly. Why? Because system is guiding for him or her. Let me give you a real shop floor example. In CNC fixtures, we use a locating pins. The part has holes matching these pins. So the part can sit only in the correct position. If you try a wrong position, it will not sit. For example, another example I will tell you. The mobile charger cable, not the C type, all the time. It fits only in one way. You don't think, you just insert. So this is prevention. System is smarter than human. And always remember, this is the best method because mistake never even gets a chance. Now the second type, detection. Here mistakes can happen, but system catches it immediately. So the damage is controlled. Let's understand clearly. In prevention, we stop mistakes from happening. But in detection, we allow operation. But we keep checking continuously. The moment something goes wrong, system reacts. For example, in a CNC machine, suppose the tool breaks. If the machine continues, part will be completely damaged. But if there is a sensor, it detects the tool break instantly, the machine stops, right? Now, what happened? Mistake happened, but the loss was controlled. Another example, part presence sensor. There's something called the part presence sensor. Sometimes the piece may not be kept on the table before pressing the start button. Or maybe some clamping issues on the piece might have flown off. If the machine, what is it? Suppose in such cases, the machine will check for the part. The machine will not start. The system checks before operation. Like some of the vehicles you can see, most of the two-wheelers now, what will happen? If you try to start with the side stand on, what will happen? Will it start? No. Why? An alarm will come that you have not placed your side stand. It detects your mistake and it helps you to correct the mistake. So detection means mistake happens, but system is alert and reacts fast. It is not as strong as prevention, but still very useful. Now the third type, warning. The simplest type. Here mistakes happen, systems also give the warning. But system does not stop you. You have to take action. In machines, for example, you see the red light blinking or the buzzer sound. That means something is wrong. And sometimes the machine may still run unless you stop it. So here the responsibility is still on the operator. Like simple daily example, mobile battery low warning. Phone will show 10%, but will it show switch off immediately? No. You have to charge. If you ignore, the phone will die. If you charge, stop and charge, it will work. Same in factory. Warning systems are helpful, but not fully safe because they depend on human response. So, if the operator ignores, problem continues. That's why warning is considered the weakest type, but it's still useful, not the best. So, always aim for prevention first, then detection, then warning. Now, let's move into the CNC machines. This is where things become very real because in CNC, mistakes are very costly. Let's think about it. Machine runs at high speed. Tool is cutting continuously. Material is expensive. If something goes wrong, there is no time to correct. Within seconds, damage happens. Let me give you a situation. You give the wrong tool offset. Machine starts. Tool goes deeper than required. Obviously, the part is damaged, or sometimes the wrong tool is loaded. Program runs. Operation fails. Right? So in CNC, we cannot depend only on operator skill. Even experienced people can make mistakes. So what do industries do? They add foolproofing. They use fixtures that guide the part correctly, sensors to detect the problem, systems to verify tool and offset. And these, instead of trusting memory, they trust the system. And that is why smart factories don't trust humans alone. They support humans with systems. Now, the coming examples, we will see some real CNC foolproofing examples. Let's take the most common CNC mistake, the wrong offset. This happens even to the experienced operators. Maybe you entered the wrong value. Maybe you forgot to update after tool change. The machine has no brain. It does not know your intention. It will only follow the program exactly as written. If offset is wrong, tool will go deeper or higher than required. Within seconds, part is damaged, material gone, time gone, sometimes tool also gone. Can we stop this? Instead of telling the operator again and again, check properly, we can use a foolproofing. What will happen? We use the tool presetters. Before running, tool length is checked automatically or offset verification system. Will the machine know it? No, the machine is not going to know. It will just run. And the result, the dimensions wrong, the part will be scrapped, sometimes even collision. So what can we do? We can use tool identification systems like tool tagging or tool measurement systems. Machine checks whether the correct tool is stored. If not, it will not start. Simple idea, but very powerful. We remove the chance of mistake. Now let's talk about the fixture. This is one of the best places for foolproofing because fixture controls the part. If fixture is designed properly, half of your problems are solved. Example: use locating pins. The part fits only in the correct position. Wrong position? Not possible. Use stopper blocks. Parts cannot move. Clamping designed properly. No vibration, no misalignment. So instead of depending on an operator skill, we depend on a fixture design. A good fixture means we have less mistake, and this example is a good example for prevention type foolproofing. Now, imagine one situation. Operator forgets to place the part. I told you already. But the machine has started. What will happen? The tool will be cutting in the air, or it may even hit the fixture. The damage is possible. So what do? We add a part presence sensor. If the part is not there, the machine will not start. Simple. Operator forgot, but system did not allow that mistake. Same idea. Some vehicles, it won't start without the clutch in place. The system checks before action. This is detection type of foolproof. Tool can break, and if the machine continues, part is completely damaged. So we use tool break direction. System checks the tool condition. If the tool breaks, machine stops immediately. So mistake happened, but damage is controlled. This saves material and saves time, and also reduces the scrap. Now, let's see why all this is important. First, less scrap, then less mistake means less rejection, better quality, output becomes consistent, it saves time, no rework, no correction, and also mainly the operator stress is reduced. No fear of making mistake. Work becomes smooth. So foolproofing is not only technical, it improves the overall system. One important thing, foolproofing is not against the operator, it helps the operator. It supports him. Instead of saying don't make mistake, we say system will help you avoid mistake. So what happens? Even a new person can work safely. Confidence increases and work becomes easier. Final message. Now let's slowly bring everything together. Throughout the session, we saw many examples: CNC mistakes, wrong offset, wrong tool, wrong setting, and we all also understood something very important. Mistakes are not always because people are careless. Mistakes happen because we are human. We get tired, we get distracted, sometimes we assume instead of checking. So, if a system depends only on human attention, then mistakes will definitely happen one day. Maybe not today, maybe not tomorrow, but one day it will happen. So, smart factories don't take that risk. They don't say train the operator more, warn him more. Instead, they ask a different question. They ask, how can we design this system so that the mistake becomes difficult or impossible. That is the shift from blaming people to improving process. Let me give you a simple example again. If a part can be placed in two ways, correct and wrong, then the mistake is waiting to happen. But if we change the design so it fits only in one way, then the problem is solved permanently. No need to remind again and again. Simple way, for example, if two plates are clamped using a dowel or screw, what we will do on one side, if we are using a screw, one side we will be using M6 screw, the other side will be using a M8 screw. So what will happen? Or M8, M10 screw. What will happen? We cannot turn it upside down or keep it because 6 will match only with 6 hole and 8 will match only with 8 hole. So in this way, if we change the design and it fits only one way, the problem is solved permanently. I told you we do not remind it again and again. That is the power of foolproofing. It works silently, it doesn't shout, it doesn't depend on mood, it doesn't depend on experience, it just works. And that is why we call it the silent savior of manufacturing. So from today, whenever you see a process, don't just think how to do this. Also think how can this go wrong? And more importantly, how can I stop this mistake from happening? That thinking will make you a better operator, a better engineer, a better programmer, and a better problem solver. So, thank you everyone for attending this webinar. I really appreciate your time for this webinar and to learn something new today. I hope this session helped you understand something and even simple ideas when applied correctly can make big difference in real manufacturing. Now, before we close, just one small update for those who are interested in learning more. Admissions are currently open for our training programs. We have a 30 days online SolidWorks course, which is designed especially for beginners, where we start from the basics and slowly build your understanding step by step. And also, we have a 45-day CNC operator come programmer course, which is more focused on practical knowledge, machine handling, learning. Because in this field, the more you learn, the more confident you become. And the more confident you become, the more opportunities come to you. If you have any doubts, please comment on the session. We'll be replying to the messages. Thank you once again, and all the very best for your future. Thank you so much.